Alright, in this video we will sketch these angles and find the reference angles, both in degrees and radians. And if we have time, we will move on to evaluating functions without using a calculator. Alright, these are all special angles, I bet. Some version, reference angle of either 45 degrees, 30 degrees, 60 degrees, or 90 degrees. But we'll see about the timing. Alright, we're going to sketch the angle and find the reference angle. So, negative, when you're moving negative degrees, you're going clockwise. In standard position, we are starting off from the positive x-axis. So, as I move, I'm going like this. So far I've gone 90 degrees. Alright, if I went all the way to here, that would be 180 degrees. Negative 180 degrees. But that's too far. So I'm not going to go that far. So I know I'm going to stop somewhere here in the third quadrant. Okay, so as far as my sketch, there it is. I've done my sketch. Now the reference angle is going to be right here. Alright, this is the reference angle. Okay, and the way I'm going to find it is the reference angle is sitting here between two things. The angle that I just did is negative 115. Okay, if I had gone a little bit further, I would have reached negative 180. So it's just a matter of the difference between these two. See how r is between these two? Subtract these two. Okay? So you don't really have to deal with the signs. You can just do 180 minus 115, and that will give you the reference angle. Alright, that is 65 degrees. Because the reference angle is always positive. Okay, so R is 65 degrees. Okay, next one. Standard position. Let us start on the positive x-axis like you do. As I move around, I got 90 degrees, 180 degrees, 270 degrees right here. Now, if I went all the way to here, that would be 360 degrees. That would be too far, so I don't want to do that. So that means I'm going to stop somewhere here in the fourth quadrant. Okay, so here is a sketch of my angle. Now my reference angle is going to be this angle right here. So let's see how it went down. Okay, what I have here is my 325 degrees. If I had kept going, I would have hit 360 degrees. So the reference angle is just the difference between these two. 360 minus 325. Okay, you should not need a calculator for this, but just in case you need to see it, that is 35 degrees. Okay, now let's switch over to radians. And they were kind enough to give us a special angle as well, so I dig that. What I'm going to do, because I see that it's pi over 3, is I'm going to draw my unit circle, okay, like you do, but I'm going to separate it into thirds, alright, because the top half of this thing is pi. So just sort of ignore the y-axis for a second, pretend like that's not there. Then if I were to separate this thing into thirds, it would look like this. Okay, again, ignore the y-axis. ignoring the y-axis, you see I've got 1, 2, 3 pieces. So the top half is pi, so each one of these is a third of pi, or pi over 3. So I will look at that as I'm finding my way around. Okay, so starting from the positive x-axis, because I'm doing standard position, what I have here is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7, 8, 9, 10, 11. Kabam! 11 pi over 3 is right here. And to sketch it, I'm going to need a curly Q. Okay, let me do that again. Alright, so I started from here, and I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 3. Alright, so there's my sketch, man. Beautiful. Okay, anyway, the reference angle is going to be right here. Alright, there's my reference angle sitting right here between these two things. I don't need to do any math this time because of the way I set it up, because each one of these slices is in fact pi over 3. So this R angle is no exception. The reference angle is simply pi over 3. Now look, that was the short way, and I was able to do that because it was a special angle. Pi over 3 is one of those ones that you memorize. Alright, pi over 3, pi over 4, pi over 6, and pi over 2. Those are special angles. But what if they'd given us like 11 pi over 5 or something like that, something that was not a special angle? Then you would have had to do it the long way. So let me show you the long way in case you care. Or, I should say in case, you don't get a special angle. This is clearly bigger than 2 pi. Alright, 3 times 2 is 6. So 6 pi over 3 would be 2 pi. And this is much bigger than that. So what we would normally do is we would subtract 2 pi from both sides to get rid of the extra revolution that takes you nowhere. And the way you subtract 2 pi from both sides is you get like denominators, right? 2 pi over 1, multiply everything by 3. So this is going to be 6 pi over 3. So I don't have enough space for this, so I'm just going to erase it. And so I've got 6 pi over 3 is the same as 2 pi. Yeah, so I've got 11 pi minus 6 pi. That's going to be 5 pi over 3. Okay, so that's the coterminal angle. In other words, 5 pi over 3 is the name of this position if I only went around once instead of going around once and then around again. It would just be called 5 pi over 3. So I can call this 5 pi over 3, and then if I kept going, this would be of course 2 pi. So the reference angle would be the difference between these two. So if I wanted to find the reference angle, and I'm doing it the long way here, I would have to go, okay, the difference between these two, the big one minus the small one, 2 pi minus 5 pi over 3. Okay, now if I multiply both of these by 3, that'll give me 6 pi over 3 minus 5 pi over 3. 6 minus 5 is 1, so that will give me 1 pi over 3, which is what I had in the first place, much quicker. Okay, so that's how you would have to do it if you had to do it the long way. Alright, let's do that one more time. Alright, once again, they were kind enough to give us a special angle. Pi over 4 is the reference angle. So, I mean, when they give you when it's radians like this, and they give you one of these special angles. The deal is that I can tell you right now that the reference angle is going to be pi over 4. Okay, I just look at the denominator, and that's going to be the reference angle. Anyway, as far as sketching it, I know that pi over 4 is like 45 degrees, okay? So what I would do if I were you, because it's a nice special angle that we're familiar with, I would draw the unit circle and sort of do it up. Okay, so if I split these down the middle, I'm creating pi over 4, because this is pi over 2, pi over 4. Okay, I'm creating 1, 2, 3, 4 slices up top. That's 1/4 of a pi. Okay, because pi is the top half. So anyway, now I can sort of count, starting from standard position, like you do. Okay, and I'm going the negative direction, so I'm going around this way. Alright, but let's count to -7. So this would be -1, 2, 3, 4, 5, 6, 7. Okay, that would be -7 pi over 4. Okay, so there it is. Okay, and as we said before, this will be our reference angle, but of course it's pi over 4. Okay, that's the way we drew it. So that's it. I'm not going to show it to you the long way, because I did that on the last problem. And it would just be annoying to do it again. Alright, I'm going to stop this video here. It's a relatively short video, but the next concept is completely different. So that is how you sketch an angle and find its reference angle.